Okay, so here what I'm doing is I am connecting all these points, or putting all these coordinates, K and L, in an X and Y plane that has L in the horizontal axis and K in the vertical axis. So here's our first point, point A, 20 capital and 125 labor. All right, so this is A. And here's our point B, 50 and 50. Here's our point C, 100 capital and 25 labor. And here's our point D, which is 125 capital and 20 labor. Okay? And if we connect all these dots, let's do this in blue, we'll get a curve that is kind of familiar to you. I bet you remember a curve like this. This looks really similar to the utility functions or utility curves we were actually seeing in utility theory. And it's not surprised we're using the same formula, same form of the function, remember? So this is what we call an isoquant. An isoquant. And it has the same properties that a utility function had, which is the slope of the curve decreases in absolute terms as you go away from the origin towards the L, towards the x-axis, right? And as the number of units of labor increases, right? You go down here, and the number of capital units decreases. Your slope of the curve is actually decreasing in absolute terms, and that's that's the fact that labor has diminishing marginal returns, and that's what we said before, right? We said that when you have very little labor, which is a D, and you want to increase your labor and decrease your capital, you can do this by replacing 5 units of capital with 1 labor, and this is right here, right? This is this point right here. But when you have a lot more labor, let's say at 50, it will take a lot longer, a lot more to actually replace that capital with labor. Right? At that point, you will need 75 units of labor to replace only 30 units of capital. So the fact that this isoquant has a diminishing, a smaller slope in absolute terms as the number of units of labor increases reflects the fact that labor has diminishing marginal returns, and the same for capital. As you increase the number of units of capital, the slope is going to get larger in absolute terms because you will need more capital in order to replace a lot less units of labor. All right, so we are gonna. This is the curve we're gonna be using in order to study production. Now, another thing you should notice is that all these combinations of labor and capital give you 50 units of output. That means the same way in which one utility curve has the same utility along the same curve, the isoquant will have the same unit of output along the same curve. So let's get rid of these points now here. What we're saying is that this isoquant along every point is going to give you 50 units of output. Now, the last thing it should be clear to you is that if the amount of output increases, then the isoquant is going to move to the right, right? Because let's say you can actually produce more output if you want, and since the form of the production function is the same, every time you produce more output, what you do is you move to an isoquant that is farther away from the origin but keeps the same slope. And the same thing if you produce less output. And you can try this on your own. What you can do is you try to do the numbers again, and instead of being 50 capital, try with 25. And just keep this curve in there, and solve for the same unit of capital, but this time for output of 25, and see what you find out, and see if in fact the isoquant is going to move. It should move inside.